Okay, time to review some stuff about routering toolpaths. I'm going to go over some common mistakes that I see. First of all, let's start with the plate because the routering is a lot more important with the plate. So I'm going to have my surface at the top of the plate. My thickness will be the thickness of the board I'm using. So usually board thickness is around 3/4 inch. It's rare that I'd have a nice big 1 inch thick board to use. Then these two sizes here aren't quite as important. You could define those however you want, really, and then you could shrink it down later on. But so here's my board. Let's pretend like this is my board. It's not bad to start off by making sure it's at the zeros. So I'm going to move it into the zero. If you don't do it now, you have to do it at the end before you send it, or else the machine's going to wander really far away from the board. It won't know where the zeros are. So typically when you're doing a router project, engraving is usually done on letters. So if I just take my letter and I go toolpath engraving, okay, it's telling me it's going to be converted to curves. Sometimes you can do that ahead of time. Most of you know this. But I'm going to be picking out a conic of some type. So conic has a V-style angle to it, right? Usually a 90-degree. And then my depth isn't going to be very much, like probably no more than 1/10 of an inch. Then I have to put in my feed rate. That's how fast it's moving across the board. The plunge rate is how fast it plunges into the board for each letter stroke or whatever it's doing. And then the RPM is how fast the spindle is turning. And this one's really important because sometimes in the past we've left that zero and it just wrecks the bit. The machine comes down and just jams the bit into the board, which causes it to wreck. So there we go. I've engraved this F. Now if I go to this right here and I hit play, okay, you can see the conic bit coming out. It's really slow right now, and it's going to carve just a little bit of depth in this F. So I selected 1/10 of an inch, and then it's going to go back to its home. So that's the zero axis right here. So remember, on the router, we actually have a little more to it. We have our z-axis. So if I look at the front view, you can see it's cutting into the board about a 1/16 of an inch. Okay, and I can see that on the right side as well, and I can kind of see it in the perspective view. So another thing that you might typically do in a router project is some sort of slot. So a lot of times at a big cabinet shop or production shop, so for example, Haworth has 40 of our CNC routers, really similar to ours. And they run those things all day long, and they're making grooves for other boards to join in, to assemble them, and slots and different holes for pegs and all kinds of stuff. And so sometimes we'll make a slot that goes all the way across the board, so to speak, for like a dado. Oops, I just made another one. So the slot might go all the way across the board. Alright, so that way you could, put in a shelf of some sort, and we want to go a little past the board on this case. If I'm trying to put a groove, like let's say I want to put a board right in there, I want to go a little further past the board because the radius of the bit. If I have it right up to there, the radius of the bit will leave like this little bump that we would have to clean off manually. So on something like this, my toolpath for this might be one of these, either island fill or hatch fill. Okay, and I'll kind of show you the difference. We're going to go back to an end mill cutter now. So end mill cutters are really flat edged, and if you look in your tool library, you can get a feel for that. So if my board is 3/4 of an inch thick, I'm going to go, approximately halfway through this board, you know, give or take. I gotta do my feed rate again, 85, my plunge rate 65, and my RPMs, I'm just gonna leave those the same, 24,000, and I'm gonna hit OK. OK. Alright, so see, this one is kind of weird. It's going back and forth, 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 and then it goes up and then down. So this is kind of a strange way that it cuts these going vertical, you know, but that's just kind of how it likes to do it. And if we rotate our whole part, you know, we could change that. Now let's see if your groove is going this way, and I go toolpath, hatch fill, I hit OK. Now notice this one, it goes right with, you know, right across, which is a lot more efficient, you know, way to do that. So let me look up here on this view again. You can kind of see I have a couple more lines. I went a little deeper on this one, so you can kind of tell in these views that it is, you know, a deeper cut than before. So then sometimes, like I said, you might have a spiral fill. So let's say I want to make a recess for like change, or, you know, something, you know, like where a peg would sit in. But I want to clean all this out, but I don't want to go all the way through the board. I would go toolpath, spiral fill, and then I'd select my end mill again. 1/4 inch end mill is the most common end mill that we have, and it holds up really good on material. So that's usually the diameter end mill that we use, because I have quite a few of them. They're still like 50 bucks a piece. If we do smaller than that, we tend to break them off a little bit too much, and that causes problems. Okay, so now I'm going to hit OK here and OK here. So now you can see it's just a spiral. It goes around, and after it goes around, it does one more big cleanup move around it. So remember, this is all wood. We're just cutting wood here. Now I need to do my outside one. So my outside, I'm going to be cutting all the way through the board maybe. So for this one, I'm going to go routing offset. And I'm going to change the, I got to change the tool first. I'm going to do an end mill. I got to delete this tool. We can't have two tools. And then I'm going to change my depth to 0.75 because I want it to go all the way through this thing. Feed rate, I'm going to do 85. And then I'm going to do 65 and 24,000. Now, one of the issues with cutting that thick of lumber, sometimes it's better to do a couple passes. So I'm going to do 3 passes. I'm going to hit OK, and I'll show you what that does. So if I go back to this view, so now you can see on this view here, it's going around 3 times now. So on the outside, it's going to go around 3 times, you know, to cut that out. And it's you know, going to be a little bit better of how it does that. So it's going to do my F first. And then it's going to change tools, so we'd have to, our machine does not have a tool changer, so we have to manually change the tools between cuts. So there it goes, it picked up the end mill, and now it's going to do this slot. And this one, like I said, is not very efficient. I don't like how it goes back and forth so much on that one. But, you know, it's okay. So now it's going to go back, and now it's going to do the cleanup. So it's going to do the cleanup edge now. So it's going to just go around that slot. And now it's going to do this slot. And this one, it's going to go back and forth just a couple times to clean up this slot. And now this one is going to do the outside, so it messed up. I don't want it to do the outside last, so that's probably where I want it to do the outside last. So that's probably where I need to go in and you know, clean that up a little bit and make sure it does this one before it goes there on the outside. So one more pass. Sometimes it's nice just to follow this through just to make sure it's doing everything right. Like just now I would have guessed it would have done that circle. It would have put that little indent in there before it did the outside, but nope, it didn't. So that's one of the reasons why it's kind of nice to watch this and see you know, if it's really doing what we want it to do. And so then it just cleans up the outside here, and that one is done. So that project's done now. So now the tool's going home, and you can kind of see that. All right.